Well, welcome everybody to Physical Science today. We're going to be talking about types of bonds. So we are talking now about chemical reactions. And remember, it all has to do with what? Chemical reactions have to do with what specifically?
Chemistry.
Well, chemical reactions make compounds.
Electrons.
And what kind of electrons?
Valence.
Valence electrons, okay. So far, the kind of bond that we have been talking about are ionic bonds. Okay? So here's the definition of an ionic bond is when ions bond due to their opposite charge. It can be shown with electron notation. Okay, so have you ever heard of the term salt? S-A-L-T.
Yeah.
And you think sodium chloride, right?
Yeah.
But anything that is an ionic bond is considered a salt. So salt is like a big term. There's thousands and thousands of different kinds of salts. And it's another term for elements combined through ionic bonds. Okay, so you guys are probably wondering what electron notation is, right? Now, do you understand the due to their opposite charge piece of this? Because we've talked about that before. We talked about the fundamental law of electricity and about how these ions will have opposite charges and they'll be attracted to each other due to their opposite charges. Okay, so ionic bonds are usually between metals and nonmetals. Okay, so if you look on your periodic table, it's the metals are going to be on the left, the nonmetals are going to be on the right, right? And if you look at the periodic table, you know that the ones to the right are going to be what? Giving or taking away the electrons?
Taking away.
The ones on the right are going to be, I said giving or taking away, which is the same thing. I meant giving or taking on electrons. Taking on is right? Because they're closer to the octet. So the chlorine only has to take on one, chlorine takes on one. Or the ones on the left, which would be the metals, are going to be closer to the octet by giving electrons away, right? So that's why these ionic bonds are usually between metals and nonmetals. Okay, so the definition of an ion then, the definition of an ion is a charged particle that has more or fewer electrons than it has protons. If it has more electrons, is it going to be negatively or positively charged?
Negative.
Negative. If it has more electrons than protons, it's going to be negatively charged. If it has given an electron away, it's going to be left with a positive charge. If it gave 2 electrons away, it's going to be left with a positive 2 charge. Okay, so cation is the name for a positive ion. An anion is the name for a negative ion. So those are a couple vocabulary words you're going to have to know. Now, how do ionic bonds form? Now, we have been talking about this for a couple days, but it's... Okay, how does an ionic bond form? Well, let's look at this. So we're talking about how does an ionic bond form right here. Let's say we have sodium. Okay, so we have sodium, and how many valence electrons does sodium have? 1, right? So we're going to signify that with an X this time. Okay? And then let's say also that we have chlorine. How many valence electrons does chlorine have? 1, 2, 3, 4, 5, 6, 7. Right? Do you agree with that? Chlorine wants to take on 1 electron, sodium wants to give away 1 electron, then they'll both have their valence shell filled with an octet. Do you agree? So what you want to do is quit writing the notes here and pay attention to this. What you want to do then is take the 1 electron from sodium and transfer it to the chlorine. So now, chlorine, you can see, has 8 electrons around it, right? And sodium actually does too, but you don't see them because they're in the second energy level. They're going to be the neon electron configuration. But what happens to sodium at this point? What kind of charge does sodium have?
Negative.
Well, it's got a positive. It's got a positive because it lost an electron, right?
Right.
So it's got a positive 1 charge. Okay. What does chlorine have? A negative 1 charge now. Right? Well, sodium lost an electron. And if you remember from the last chapter, the number of electrons and protons are equal.
Right.
If you lose an electron, then you have one more proton than electrons, which means you have a positive 1 charge. If you gain an electron, then you have a negative 1 charge. Now, what's going to happen? These two are going to be chemically attracted to each other now through the force of electricity. Because they have opposite charges. Fundamental law is that these two things, well, the fundamental law of electricity is opposite charges attract. Okay, so now what we're going to end up getting is sodium chloride. And that's how they form a new compound. Now, let me put this back here. That electron of sodium. So, when we do a transfer diagram, what you're going to want to do is draw in this. So this is the electron. It's going to transfer into over there. And so then you end up getting this -1 plus 1. And then you have your new compound. Okay? We'll do a bunch of practices like that. Do you basically understand this idea though?
Yeah.
Okay. Okay, so just to kind of refresh what we said, the metal is going to be the one giving away the electrons. And so the metal is going to be the atom that's called the cation. For example, sodium plus is a positive ion or cation. Okay, this requires energy. Anytime there's going to be a transfer of anything, it's going to take energy to do that.
Well, that's all. Why can't we just write out energy? Why don't you just write? Because I thought NRG was something else. Like I thought it was.
No, energy is spelled that way. You'll see that in college all the time. So we do it in high school too. NRG.
Because it sounds like energy.
Yeah.
Why?
Okay,
What's the
so the question is, what's the name of this? What's the name of this ion right here?
sodium plus?
It's called,
The cation.
it's a cation, and it's called sodium ion. See how easy it is to name that? It's the name of the metal plus ion. Okay, so the non-metal, so if the metal is giving away the electrons, the non-metal here takes on the electrons. And this is just, putting in words what we were just talking about there. Okay? So here is your electron notation for what we just talked about. So I'm going to give you a worksheet today. And what you're going to have to do for the worksheet is put both of the electron dot diagrams around each atom. So this is the dot for sodium. And I want you to use two different symbols. So you could use a dot and an X, or you could use a dot and a open dot. So those are the two, that's your first step. And then showing this arrow, showing where it goes, is the second step. So it's important that you understand that this valence electron is actually moving onto the other atom. So this electron is more attracted to the chlorine than it is to the sodium. But keep in mind, those two particles have to hit each other with the right energy in order for this to happen. And then the second step will be showing this. Now you have an octet around the chlorine, and the sodium looks like it doesn't have an octet, but keep in mind it has the octet of the helium, or the neon atom. And then this is the final answer, NaCl, and you show the +1 and the -1. Okay? So here's one for potassium and fluorine too. But I wanted to see you do one for magnesium and oxygen. Why don't you go ahead and do that in your notes, and then we'll do it up here together. Magnesium and oxygen. Do an electron transfer diagram for magnesium and oxygen. Good.
Seconds of silence.
Okay, so for my dot diagrams, I've got 2 for magnesium, right? And then for oxygen, I've got 1, 2, 3, 4, 5, 6. Right? Okay. So now, the next step is to show these move in to their respective places. And now, the next step is I'm going to have Mg, which looks like it has no electrons. I'm going to have the oxygen, which has its own electrons. And then it also has the Mg electrons. So those are the first 2 steps. And then finally, the last step, or the answer, is going to be MgO. And you want to put on their charges. What are the charges going to be for these? Mac?
Negative +2.
Yeah, so this is going to be a +2 for the Mg. This is going to be the -2 for the oxygen.
Wait, why would that Mg?
So the question is, why do the electrons from magnesium go to oxygen? Well, look at the total number of electrons that magnesium has to get rid of. It's 2. If it gets rid of 2, it's going to be dropping back down to a neon noble gas electron configuration. So if you look at your periodic chart, you'll be able to see that. So either oxygen is going to give away 6 and magnesium is going to gain on 6, or the other way. Which one's easier? The one with less. And when it comes down to it, it's a kind of an energy thing too, you know. So the things with the least amount of energy should probably happen. You can think of it that way. But there is more to it than just that. It really comes down to the force of electricity. And I'll show you a little picture of atomic radii. Okay, so this might help clear up that question a little bit more. But look at, these are the sizes of the atoms. So if you think of sodium in the valence shell, like the valence shell is going to be, on the outside, right? Because that's going to be the highest energy level, kind of on the outside. Okay, and then if you look at, what was the other one we had in mind? Oxygen right here, right? There's the valence shell right there. Now look at, oxygen is going to have 8 protons, so it's going to have a big pull in its nucleus for electrons. Because the protons are positive, the electrons are negative, so they attract. The electrons stay around the atom because of the proton pull. Well, sodium is going to have 11 protons, but if you look at, so it's going to have more of a pull, but look at, keep in mind that if this is the actual size of the sodium atom, then your thumb being just the protons in the nucleus, like this atom would be like as big as to the other side of of Gateway Mall. On the other side, over by A&B Pizza. And then that much further north of here too. So there's a lot of space. And you think that right in the very center, and only in the very center, in a spot that you wouldn't even be able to see, according to this picture, that's where the pole is. So if you know the force of electricity has an inverse square relationship with the distance, then if you're looking at this distance, you're going to have a force. That's not even a very good force picture here, but you're going to have a really high force because there's a small distance. So it's going to be a really high force for this small little atom. But over here, you're going to be, much further down in the radius, and so you're going to have a much weaker force that's pulling on these electrons. So ultimately, the reason why oxygen gets these electrons added to them is because the proton pull is much, much, much stronger on the outside of this atom than it is on the outside of that sodium atom. Any questions about that, you guys?
So many.
Where to start?
So this stuff is like more kind of the physics of it and the understanding. I'm glad you asked the question. I'm not going to have you really, get into that fully, but it might help you understand why the sodium is getting rid of its electrons and the chlorine is taken off. It's because the proton pull from the inside is so much stronger in the valence shell of a chlorine than it is of a sodium. Okay, so now look at this. Our next note is more than one electron can be transferred from or to each atom. We already did that. We already did the magnesium and oxygen one, right? So we just showed an example of that. An oxide ion, okay? How many electrons did that oxygen get? Well, first of all, Riley, did it get electrons or give electrons? It got them, right? And how do we know that? Because it has a more negative charge. And an atom can never give away protons. It's always the electrons. How about aluminum +3? What happened there? It lost how many electrons? It lost 3 electrons, leaving it with that 3 more protons than electrons in its atom. Okay, so here are some electron notation examples for, we just did this one already. Magnesium and oxygen, we did that together. Calcium and chlorine, there's another example. Now look at this one. This one is more interesting. Let's do this on a different piece of paper here. We're going to do calcium and chlorine for an example. Okay, so let's put together calcium plus chlorine. Okay, so the first thing you have to do is the electron dot notation. Calcium has how many electrons in its valence shell? 2. So I'll put those right here. Chlorine has 7. 1, 2, 3, 4, 5, 6, 7.
So you added 1, right?
Okay, so chlorine can take on 1, right?
Yes.
Okay, so we're going to show that. Okay, and so this one right here is going to move into the chlorine position. Okay, now does the chlorine have an octet?
Yeah.
Yeah, it does, so that one's happy. What's the charge on the chlorine? -1, right? Okay, but now is this calcium happy yet?
No.
So now what does it have to do?
Lose the other ion.
It has to lose the other electron. So we never get one atom of anything separate. So if there's one chlorine atom, there's going to be multiples. So now we're going to have to add another, or we're going to have to show another chlorine. Okay, So we got 1, 2, 3, 4, 5, 6, 7. Okay. Now this electron can move down into that position. Now I have a -1 there. Now is the calcium happy?
Yes.
Okay, so the final answer to this then is calcium. No. Okay, yeah, calcium plus 2, right? Cl what?
2, subscript 2.
2,
Minus.
Then minus.
which this side is -2.
That's awesome.
Okay.
We get it out.
So this -2 though is for both the chlorines added together. It's not for each one.
Well, what if there be 3 chlorines and it'd be Cl3, -3?
That's exactly right. So you want to go even a step further and do one that's a little bit harder than this?
Yes, please.
Okay, let's do that, and then you'll be good to go for chemistry. So let's go. Let's go with calcium plus, let's say, phosphorus. Calcium plus phosphorus. Okay,
2 and
so we have 1, 2, and then we have 1, 2, 3, 4, 5. Okay. Yes. So now you just start filing in electrons. So show this one's going to go here. Okay. This one's going to go here. Okay. Does phosphorus have 8 around it?
no, that's that.
It's got 7. So now what do we got to do?
Add another C.
Add another calcium. Okay.
There's gonna be one left.
Well, then we can put this one over here.
1, 2, 3, 4.
Is that phosphorus happy now?
Yeah.
So there's 8 there.
But calcium.
So calcium's not, so now we gotta do another phosphorus.
No. Oh,
It's gonna take forever.
No, it's not. Just be patient.
Yes, 3.
Okay, there,
No,
right?
I said. Stop.
Let's do another calcium because we have more to spare, right? This one will go in here. This one will go in here. Now are they all happy?
Yes.
Okay, then now that they're all happy, we can draw the formula. So now we can predict what actual chemical reaction happens. What would it be? Ca?
3, -2.
-6.
Okay, so -6 for this side. And P2, right?
Yeah.
And that's gotta be, that's +6. And this is -6. And that's for like that side of the ionic bond.
So wait, so for that +6 -,
Okay, so these are the next notes. What happens when we have an ionic compound? We form what is called a crystal lattice. So if you look at this, you can see that there's a regular repeating pattern. That's what a crystal is, a regular repeating pattern. And as you can see, it's an alternating plus-minus pattern where sodium's plus, chlorine's minus, sodium's plus, chlorine's minus, sodium's plus, chlorine's. Do you see that?
yeah.
And so that's the way any salt comes together. So in order for us to say that there's one molecule of salt is incorrect. What we call that is a formular unit. Or formula unit. Formular or formula unit. I am. So look at this. This arrangement causes a very strong bond. So therefore, because we have a strong bond, we have a high melting point, but then we also have brittleness. So when it breaks, it's brittle, it doesn't bend. And we also have a high boiling point. So these characteristics are all because of this regular repeating plus-minus crystal lattice. Okay. Okay, so that's where we're going to stop for today. Any questions? Okay, so turn the lights on and we'll practice this.